In order to detect the outliers in the quantitative variables, we can use the box diagram. In order to do this, we can use the ggplot function that lets us generate statistical graphs. So I'm going to use ggplot. I got a double P here. Let me erase it. And the database that I'm using right now. And I'm going to tell it what are the variables that I would like to cross. So X would be just one label, which is yield. In Y, I want the yield variable also. And I also tell them that I want a box plot graph. Doing this revision means that I had to do one of these graphs for each one of the quantitative variables, which can be a little tedious, but it's one of the most effective ways to identify those outliers. We can see that at least the yield does not have any inconveniences, any outliers. It's within the range and the minimum and maximum ranges. If we wanted to add the different quantity values in just one graph, we could do the following process, which is something that I usually do whenever I'm cleaning these databases. So first of all, we have to create a database where I separate all the quantitative variables. So I can do this, all right? Base de datos cuantitativas, which translates to quantitative database. And what I'm going to do is to use this function from the deep layer package that allows me to select a subset of columns with certain rules. So I'm going to tell it that from the maze database, I would like to select only the ones that are numerical. So let's see what's the result. I'm always using summary whenever I do these types of cleaning and data processing exercises to make sure everything's okay. And by doing this, we can see that all quantitative variables have been separated here. And I can also generate my box plot graphs. But what I would like to do right now is to do a graph where in each one of the boxes, these variables will be represented in order to do a fast inspection of the database, and then I'll be probably able to verify my points. So in order to do this, I would have to combine some of the functions that we saw in the videos for how to process databases. So I'm going to use this function that will allow me to convert all these variables, these quantitative variables, into two different columns so that it's easier to read them from ggplot and to do that graph that I would like to do. So I'm going to create a database, a quantitative database. It's going to be the second one. And what I'm going to tell it is that I'm going to use the gather function to transform this database into a new one where a column is going to be the name of the variables that are here, and the other column would be the corresponding values. Since I'm not going to explore the ID in my box plot graph because this is not a variable that has any outliers, and I'm not going to include it in the analysis just to make sure that all data is okay. So I'm not going to take it into account. So what I'm going to do right now is I'm going to call this a quantitative database. I'm going to remove the first column, and I'm going to tell it that the first column that's going to be transformed is going to be called variable or variable, and the one for the values is going to be called valor, which translates to values in Spanish. So I'm going to see this database with a head that's called Base de Datos Quantitative. The first 15 rows, and this is the structure. In one column, I have all the different variables and the names of the variables, and these are the values. And this will allow me to generate the graph, my box plot graph. And you're gonna see how nice it looks. So after doing this, I can start doing my graph. So let's begin by using the ggplot function. I'm going to use the database that I just created, Base de Datos Quantitative, and I'm going to tell it that the AES structure in X, I can have the value of the variable, but in this case, for the type of graph that I'm going to use, the name is going to show up on top. So I'm going to tell it that I don't want to add anything in X, in the X label, and in Y, I would like to have the value of the variable that would be this one. And I'm going to tell it that I want to do a box plot with this. And this is when the magic happens, when I use the facet wrap function to tell R that I want to have separate graphics or graphs for each one of these variables. So for facet wrap, I should include this symbol. And I'm going to tell that I want to divide it on the variable column. And since each one of these variables have different scales or values, some have 600, others 50, others 60, then those scales should be free. They should not be fixed. So I say scales and I add free. And since it's going to be a big graph, I don't know how many variables we have. I think it's 29 different variables. So let's see how the graph looks like. So I'm going to generate an additional screen to generate this graph. So I can use this function, Windows, and as you can see, a pop-up window comes up where I can see my graph. So now I'm going to hit Control Enter. It's going to take some time to generate it. And this tells me that some rows have lost values. It's just a warning. And we can go back to the graph. And this is it. Now we can identify all the different variables, and we can assess that each one of them, that almost of them have outliers. They're not necessarily shown as outliers per se in the box plot graph. This just tells us that these are values that we have that are correct, and they don't alter the analysis. Sometimes they're not as bad as we had a category that had a low frequency. So we can always analyze this also. We can analyze this with the experts that are working on this, with whoever inputted information, the data, and we are the ones who determine what is going to be done in the end. So I'm not going to expect each variable. For example, right here, I see that there's an outlier, but this is a variable that's going to be removed, so I'm not going to pay attention to it. But for example, the cycle length, apparently there's a cycle that has less than 40 days. And considering that this is maze, obviously it would be magical maze. So this is an error. And we can rectify the dates or try and correct the error from dates, and we can replace it here. Or we can transform this into a missing data point. And afterwards, when we carry out the analysis, we decide which procedure we have to carry out in order to have an estimate. And there's another variable here, that's density. I just noticed that there's an outlier there on the seats. Let's look for it. Density, here it is. So there are two outliers. So my decision in this at this moment is to transform them in NAs, and then I can continue generating the database. And afterwards, when I'm filling up the missing spaces, the missing data, which would be one of the next training sessions, then I'll be able to have another estimate for those values. So let's do it in the R console. And to remove those outliers from the database, we can do it by using this function that we've used before. It's called it's going to be done on the maze database. So let's use the mutate function once again and use it on the base de datos maze. And I'm going to start editing those variables that have outliers. So we said before that it was the plant density and the length of the cycle. So I'm going to read those names to make sure that they're properly written. So plant density is here. I'm going to put it here on the variable that we want to modify. And I'm going to add this function that's called if-else that allows me to modify a variable by modifying some rules. So in this case, I'm going to say that the rule is that if plant density was here is higher than 400,000, I would like for these values to be included in NA. Otherwise, leave the original values. So I'm going to use this rule, plant density over 400,000, then NA, or keep the same values otherwise. I'm also going to add the following rule with the cycle length variable, longitud de ciclo, cycle length. I'm going to indicate by using the if-else function for cycle length. Let's see the rule once again. It's here. And I can tell that if it's below 80. And that's how this outlier is going to be identified. So in this case, it would be an NA if it's higher than 80. Otherwise, it's going to maintain the value. So what we're going to do now is execute once again this line in order to do the updates, and then execute this graph once again. We can use this code line, and the idea is that once these modifications are performed, these outliers won't be shown anymore. So let's make sure it happens. Here they are. So this is it. Remember that we carry out a whole process to update the structure of the database. So we have to execute the whole process once again. I have to do this gather step once again when we choose the database and we restructure the database. So I have to go back again and execute these lines once again. So I execute them. And now we can revise what we did. Now you can see the density does not include those outliers that it had before. They're over 400,000. So they were removed and left as NA, and the cycle length also has a more centered distribution. So we've properly cleaned the database. So I'm going to erase this line because obviously we have to execute these lines once again from above to generate the graphic correctly and to know if we did a correct cleaning of the database.